Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is Modular Arithmetic. Lesson 6, Commutative and Associative Properties of Modular Arithmetic. In binary operation, that is operation involving two terms, with symbol asterisk, commutative and associative properties can be defined as follows. Commutative property: if we have two elements, it follows that A asterisk B is equal to B asterisk A. For all A, B, they are members of the real numbers set. This symbol denotes the set of real numbers. The second property is associative property. Here we have A asterisk B as one term, then asterisk C is equal to A asterisk bracket open B asterisk C bracket close. So in this property, we are taking A, B as one term, then B, C is another term. For all A, B, C member of the real numbers set. They are members of the real number set. Real numbers can be rational, irrational, and a set of whole numbers. Addition and multiplication are commutative and associative, but subtraction and division are neither commutative nor associative. So in this aspect, what we'll be dealing mostly with is addition and multiplication in modular arithmetic in respect to commutative and associative properties. We have examples. Number 34. An operation asterisk is defined on the set S with elements 1, 3, 5, 6 by M asterisk N equal to M plus N plus 2 modulo 7, where M, N are members of the set S. Required. Figure 1. Draw the table for the operation. 2. Using the table, find the truth set of A. 3 asterisk N equal to 3. B. N asterisk N equal to 3. C. Given that M asterisk N equal to M plus N plus 2 modulo 7, show whether or not the operation under asterisk is commutative. D. If K is a subset of S, show whether or not the operation under asterisk in M asterisk N in brackets, then asterisk K equal to M asterisk bracket open N asterisk K bracket close is associative. Let us take the solution bit by bit. Solution from the given question, this is the set, then this is the operation in modulus 7, and we are told that Mn are members of the set S. So we should draw the table for the operation. The operation has 4 elements, 1, 3, 5, 6, which you arrange column and row wise. Okay, so you take the first element in the first row, that is 1, and the one in the first column, that is 1 asterisk 1, what you have here. So 1 asterisk 1 means M is equal to 1 and N is equal to 1 also. So in the operation, you have 1 plus 1 plus 2, that is equal to 4. 4 is an element in modulus 7, so you have 4 modulo 7. That is the 4 that you have here. Then the next one, still on the first row, you have 1 asterisk 3 in this form. So in this form, M is equal to 1 and N is equal to 3. In the operation, where you see M, you replace it with 1, and where you see N, you replace it with 3. So you have 1 plus 3 plus 2 equal to 6. Equal to 6. 6 is an operation in modulus 7. So this place is 6, not 4. So this is the 6 that you have here. Still on the first row, you take 1 asterisk 5. That is 1 asterisk 5, which means M is 1 and N is 5. So you have 1 plus 5 plus 2 equal to 8. And 8 is not an element in modulus 7. If you divide 8 by 7, you have 1 remainder 1, and we are interested in the remainder only. So you have 1 here. Still on the first row, you take 1 asterisk 6 in this form, where M is equal to 1 and N is equal to 6. So you have 1 plus 6 plus 2 equal to 9. If you divide 9 by 7, you have remainder 2. That is the 2 that you have here. Now I'm considering 3 asterisk 5. That is the 3 you have here, and this 5. So 3 asterisk 5 means M is equal to 3 and N is equal to 5. So you have 3 plus 5 plus 2 equal to 10. If you divide 10 by 7, the modulus, you are left with 3 as the remainder. That is the 3 you have here. If we jump the last one, 6 asterisk 6, it means M is 6 and N is also 6. It follows that 6 plus 6 plus 2 is equal to 14. If you divide 14 by 7, you have 2 remainder 0, and we are interested in the remainder. That is why here is 2. If you do the same thing for the rest element, you have the result in the table. So this is a table for the operation. Question 2, part A. Using the table, find the truth set of 3 asterisk n equal to 3. What that means is 3 asterisk n equal to 3 modulo 7. So the element 3 is what you have in the row. So this is the 3 here. The remainder is 3. So we have 3 here. In the second row, we only have 3 as a remainder in this place. So you look the column, which element was paired with 3 to get remainder of 3. That element is 5. It simply means that n is equal to 5. So 3 asterisk 5 is equal to 3 in modulo 7. So n is equal to 5. Question 2, part B. Using the table, find the truth set of n asterisk n equal to 3 modulo 7. So under the given operation, n asterisk n simply means m is equal to n and n is equal to n as well. So the operation becomes n plus n plus 2 modulo 7. So we look at two the same pair that will give the remainder of 3. So we take 1 asterisk 1. The remainder is 4, not 3. So that is out. You take 3 asterisk 3. The remainder is 1, not 3. So you take 5 asterisk 5. The remainder is 5. Then you take 6 asterisk 6 and the remainder is 0, not 3. So from the table, no pair is true. We need to try 2 and 4, the remaining elements in modulo 7. Though 2 and 4, they are not in the table, but they are elements in modulo 7. So we try. If n is equal to 2, that means you have 2 asterisk 2. That is 2 plus 2 plus 2. The last 2 is the 2 you have in the operation. So modulo 7, when you add, you have 6. 6 is not equal to 3. So when n is 2, the set is not true as well. So let's try 4. 4 asterisk 4. That is 4 plus 4 plus 2 modulo 7, and that is 10 modulo 7. 10 is not an element in modulo 7. So you divide 10 by 7 and you have 1 remainder 3. So 3 is what we are looking for. So the set is true when n is equal to 4. N is equal to 4. That is the result. Question C. Given that m asterisk n is equal to m plus n plus 2 modulo 7, show whether or not the operation under asterisk is commutative. So it means that m asterisk n is equal to n asterisk m for the operation to be commutative. So we have two parts here, or two sides, the left hand side and the right hand side. The left hand side is m asterisk n and is equal to m plus n plus 2 modulo 7. The right hand side is n asterisk m. This then means n, the one that comes first now, plus m plus 2 modulo 7. That is the right hand side. For us to really show that the operation is commutative, if we try two elements in the given set, we should have the same remainder. That is the meaning. So let's try. If m equal to n, if m equal to 1 and n equal to 3. So we take 1 asterisk 3. So here m is 1 and n is 3. In the given operation, you have 1 plus 3 plus 2 equal to 6 modulo 7. 6 is an element there. Then if we take 3 asterisk 1, so here now we are looking at the second operation now, the right hand side. So n is equal to 3 and m is equal to 1 in this part now. So you have 3 plus 1 plus 2 is equal to 6 modulo 7. That is the right hand side. So you notice that the remainder is the same for both sides. So this shows that m asterisk n is equal to n asterisk n, and the operation is commutative because we have the same remainder from the left hand side and the right hand side. Question D. If K is a subset of S, show whether or not the operation under asterisk in bracket open m asterisk n bracket close asterisk k is equal to m asterisk bracket open n asterisk k bracket close is associative. So since K is a subset of S, we have to prove that the left hand side is equal to the right hand side. So here we need to define two operations. Already m asterisk n is known, that is m plus n plus 2 modulo 7. Then we define for n asterisk k. So we replace, where we see m, we replace it with n, and when we see n, replace it with k. That is n asterisk k, and that is n plus k plus 2 modulo 7. So we have two sides, the left hand side and the right hand side. So we take the left hand side, that is bracket open m asterisk n bracket close asterisk k. So this is the same expression here. So what it means is that when we come here, anywhere we see m asterisk n, we use m plus 2, m plus n plus 2 to replace it. That is the meaning. So anyway we see m asterisk n, it becomes m plus n plus 2 asterisk k, and we are now adding both because the operation is addition. So when you add both, you have m plus n plus 2 plus k, then plus this 2, the 2 you have in the operation. When you add 2 and 2, you have plus 4. So the left hand side is m plus n plus k plus 4 modulo 7. You take the right hand side, that is m asterisk bracket open n asterisk k bracket close. So this is the same expression. So where we see n asterisk k, we use this expression to replace it, and that is what you have here. The operation is addition and the other constant 2 is added to it. So you have m plus n plus k plus 2 plus 2 modulo 7. So when you add 2 and 2, you have plus 4. So the right hand side is m plus n plus k plus 2 modulo 7. When you check both results from the left and right hand side, they are the same. So the operation under asterisk is associative. That is the meaning. Let us try numbers in place of the letters and see the outcome. From the given sets, let's say m is equal to 2, n is equal to 3, and k is equal to 5. So we want to show that bracket open, m asterisk n bracket close asterisk k is equal to m asterisk bracket open n asterisk k bracket close. Already we've defined m asterisk n as this and n asterisk k as this. Using the numbers, we therefore have bracket open 2 asterisk 3 bracket close asterisk 5 is equal to 2 asterisk bracket open 3 asterisk 5 bracket close. So we take the left hand side. So let's relate this to this. So here we can say that 2 asterisk 3 is simply 2 plus 3 plus 2. You see that? This is what you have here. Then asterisk 5 modulo 7. So if you add the elements here, you have 5 asterisk 7 modulo 7 asterisk 5 modulo 7. Okay, so let's get 7 asterisk 5. So here again we are taking m as 7 and n as 5. So we have 7 plus 5 plus 2, and that is 14. Divide 14 by 7, you have 2 remainder 0. That is 0 modulo 7. We take the left hand side, we start with the operation in the bracket, that is 3 asterisk 5. We relate that to this. So where you have 3 plus 5 plus 2 in this form. So when you add these elements, you have 2 asterisk 10 modulo 7. So we have to simplify 2 asterisk 10 modulo 7. So we are taking n as 2 and k as 10. So you have n, that is 2 now, plus 10 plus the additional 2, that makes it 14. To divide 14 by 7, you have 2 remainder 0. So we have 0 modulo 7. So if you check the results for both sides, it is equal. So the numbers also show associative property under the operation asterisk. Hello. Example 35. Construct a multiplication table in modulo 7 for the set h equal to 1, 2, 5, 1, 2, 3, 5, 6, and use the table to evaluate 6 times 2 times 5. Then find n in n times 6 equal to 2. Show that the operation under multiplication, bracket open 6 times 2 bracket close times 5 is equal to 6 times bracket open 2 times 5 bracket close is associative. Find m in m times 3 equal to 6. Find n in 5 times n equal to 1. Show that the operation under multiplication in 6 times 2 equal to 2 times 6 is commutative. Let us find out the detail to this problem. So we start by constructing the multiplication table in Module 7 for the set with the elements 1, 2, 3, 5, 6. So you arrange the element, row, and column. So this is multiplication. If you use the first element in the row to multiply each element in the column, 1 times 1 is 1, 1 times 2, 2, 1 times 3 is 3, 1 times 5 is 5, 1 times 6 is 6. You do the same thing. So let's take the last element in the row. So 6 times 1 is 6. 6 is an element in Module 7. Then you take 6 times 2 is 12. 12 is not an element. Divide 12 by 7. You have 1 remainder 5. This is 5 you have here. Then 6 times 3 is 18. If you divide 18 by 7, you have 2 remainder 4. That's the 4 you have here. 6 times 5 is 30. Divide 30 by 7, you have 4 remainder 2. That is what you have here. Then 6 times 6, 36. Divide by 7, you have 5 remainder 1. There's a 1 you have here. So the same operation is needed to complete the other part. So 1, we are asked to use the table to look for 6 times 2 times 5. So let's take the first two numbers. That is 6 times 2. 6 is row and 2 is column. Their point of intersection is 5. So 6 times 2 is 5. If we replace this with 5 now, we are left with 5 times 5. 5 times 5. So the 5 is row, second 5 is column. Their point of intersection is 4. So 5 times 5 is equal to 4 modulo 7. If you don't want to use the table, you can do it directly. We are asked to use the table, but directly we have 6 times 2 times 5. Now 6 times 2 is 12. Then 12 times 5 is 60. What you do is that you divide 60 by 7 and you have 8 remainder 4. Remember, 4 is the answer. The remainder is the answer. So therefore 6 times 2 times 5 is equal to 4 in modulo 7. Round figure 2, find n in n times 6 equal to 2. From the table, the n is for row and 6 is column. So let's look at column 6. If you look at column 6, where you have remainder of 2 is this. If you trace the 2 to the row, you have 5. So it is 5 times 6, that is 2. Therefore, n is equal to 5. Now figure 3, showing associative property for this expression. We take the left hand side first, and if you take 6 times 2 is equal to 5. If you replace 6 times 2 with 5, you therefore have 5 times 5. From the table, you have 4. You have 4. Then the right hand side, you start with the term in the bracket. That is 2 times 5 equal to 3. This is what happened. This is 2 and this is 5. Their point of intersection is 3. So 2 times 5 is equal to 3. If you replace 2 times 5 by 3, you therefore have 6 times 3, that is equal to 4, modulo 7. You take 6 for the row and 3 for the column. Their meeting point is remainder 4. So since the left hand side is equal to right hand side, we can state that the operation is associative. Hello. Rough figure 4. Find m in m times 3 equal to 6. From the table, you take m as the row element and 3 as the column element. So let's start with 3. So you trace 3 to where you have remainder of 6, and if you trace 6 to the row, you have 2. So from the table, it is 2 times 3, that is 6 modulo 7. Therefore, m is equal to 2. We should find n in 5 times n equal to 1. 5 is the row element, while n is the column. So we start from the row since 5 is known. So you start with 5 and trace to where you have remainder of 1. When you take it up, it means as 3. So from the table, it is 5 times 3, that is equal to 1. So therefore, n is equal to 3. Then lastly there, you should show that 6 times 2 equal to 2 times 6 is commutative. That means both operations should give you the same remainder. So from the left, 6 times 2 is equal to 5. This is 6 and you have 2. Their meeting point is 5. From the right, 2 times 6 is equal to 5 as well. So this is 2, the row element, and 6, the column element. Their meeting point is also 5. This shows that the operation is commutative. Hello. End of lesson 6. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not safe, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared. Take good care of yourself. Stay out of trouble. Do the needful at all times. And don't forget, study your books. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.